welcome to CEC lectures. Myself Dr. Preeti Jagmani from Department of Computer Science, Aribhat College, University of Delhi. In our present series of database management systems, we are going through SQL. In our previous lectures, we have seen the basics and some commands of structured query languages. Structured query language, the acronym for this is SQL. We were going through the select clause. We will typically take a quick recap of what we have done in SQL, and then we'll begin with our today's lecture. So we have seen the history, the different versions, and why this SQL language is being used. As a relational algebra was there, it was kind of, we can say, a query language for relational databases, and so is our SQL is. In SQL, we are going to write some queries that may belong to either to data definition languages, which is DDL, or DML, data manipulation languages, or it could be data control languages also. So presently within that we are going through the select clause, and we have also seen that select clause can contain arithmetic expression which may involve the operation of addition, subtraction, multiplication, division, and these operations can be done on either the constants or on the attributes of the tuples. So with this, let us take an example which we have also seen earlier, that is select ID name salary divided by 12 from instructor. So in our instructor table, if you recall the structure, there are 4 fields. One is ID, another one is name, third one is salary, and the fourth one is department. So from that, first of all, we don't need department. That's why we have not specified the name of the field department here. We have only specified the 3 fields, which are ID, name, and salary. And that too, in salary we have in our instructor table, the salary which is written there, which is fed there, is actually the annual salary. Now what if someone wants the identification or the name of the instructor and the monthly salary which he or she is getting? Then that salary has to be divided by 12. So one operation of division is directly done on the attributes of tuple as select ID name divided by salary, select ID name salary divided by 12 from instructor, and you all are aware that instructor is a table here. Also, let us say if we want to rename this salary divided by 12. So because this is going to be the resultant field in the resultant relation. So the fields will be in the result, the fields will be ID name salary divided by 12. Now if someone wants to rename this salary divided by 12 using by monthly salary or any other kind of more appropriate field name, that can be done using the as clause, as. So this will be select ID name salary divided by 12 as monthly salary from instructor. So ultimately we are going to get, after this command, we are going to get a resultant relation in which there will be 3 fields. One is ID, another one is name, and third one will be named as, or third one will be tagged as monthly salary, which is the salary divided by 12. What the original salary was given in the instructor table, that salary divided by 12 will be given here. Now if we want to specify some conditions that the resultant relation must hold, we have the where clause. So with this where clause, this corresponds to the selection predicate of relational algebra, and relational algebra we have seen earlier. So in this we are going to take an example, that is to find all the instructor in computer science department. We are going to write select name from instructor and where, then we will be specifying clause where department name is equals to computer science, that we have seen earlier. Also in this we can involve some comparison using numbers, comparison with the numbers using logical connectives like AND, OR, and NOT. So for example, if you want to find all the instructors in computer science department where salary is greater than 80,000 or with salary greater than 80,000. So, this is going to be a very simple query to write, which will say select name from instructor where department name is equals to computer science and salary greater than 80,000. So, these comparisons can be applied to the results of arithmetic expressions also. So, here we have seen that this where clause is going to specify the conditions which a resultant relation has to satisfy, and these this may not be essentially one individual condition, but you can use multiple conditions with the help of logical connectives like and, or, and, not. So, now our the next clause which we need to study is the from clause. The from clause, as we have seen from instructor. So, from instructor is one version of the from clause, but if we are going to involve multiple relations in this from clause, this is going to correspond to the Cartesian product operation of the relational algebra. Please recall that in relational algebra we have seen one Cartesian product. So, here if we want that particular Cartesian product operation to implement, we are going to use from clause with more than one relations. So, here what are we going to do in this example? We will be finding a Cartesian product of two relations. One is the instructor relation and another one is the relation which is teaches. So, what are we going to write here? That in so first of all let us look at the structure of the the tables which are available for this Cartesian product. So, one is the instructor, in which we have ID, name, department name and salary, and another one is the teachers which is having ID, then the course name, then the course ID, semester and year. Now, what the next table which is teaches is having the fields as ID, then it is having course ID, then section ID. Sorry for my earlier mistake, it is section ID, not the course ID. Then we have semester and then we have year. So, now here if we want to take a Cartesian product, what will happen? The ID or the first row of your instructor will be taken in combination with all the rows of the second table. Then the second row, which is 1 2 1 2 1 ID, will be taken with all the rows available in the next relation, which is teachers. So, here you can see, and finally the resultant number of rows will be, let us say, n number of rows are there in the instructor and m number of rows are there in the teachers. So, finally it is the finally resultant relation will be having n multiplied by m. So, here you can see the first row which is 10101 ID is taken, and all the rows of your teachers relations are given with this, and in this way this Cartesian product is going to take place. Now, how are we going to use the from clause in order to find the Cartesian product in SQL? That is something. So, we are going to simply write select star from instructor comma teachers. So, select star from instructor comma teachers is going to give you every possible instructor teachers pair with all the attributes from both the relations as we have just seen. And for the common attributes, for example, if we have common attributes, let us say ID. So, these common ID is available in instructor as well as ID is available in teachers also. So, for these type of common attributes, the resultant table is going to have ID prefixed with the name of the relation. So, for example, instructor dot ID or teachers dot ID. So, this is going to be the result of this. These Cartesian products are not very useful directly, because they will be useful when combined with where clause condition, where this where clause condition is corresponding to the selection operation in our relational algebra. So, here we have seen that the fields are there for instructor relation and for teachers relation, and if we are going to say select star from instructor comma teachers, this is going to give me a simple Cartesian product of both the relations, both the tables. Now, apart from that, if we want to apply some filter or some we can say where predicate onto the result of the Cartesian product or along with the Cartesian product. So, here is the example. If we want to say that we want to find names of all instructors who have taught some course and the course ID. So, we want to have the name of the course, name of the instructor and the course ID. This is going to we are going to get this from the Cartesian product of instructor and teachers, but we want name of all instructors who have taught some course. So, taught some course is actually the entry in the teachers. So, we are going to find, or we actually want to find all those instructors which are available in the relation or in the table teachers, because those are the instructors those who have taught at least one course. So, we will be looking for all those ID inside the teachers which are available in the instructor. So, basically what are we going to do here? We will be saying select name comma course ID, because these are the two fields which we are requiring from instructor comma teachers. So, this is till this point, this is simply a kind of we can say projection applied on the Cartesian product, but along with this we are also going to say where instructor ID is equals to teachers ID. So, whatever IDs are available inside the teachers ID, only those IDs will be taken from that with the help of this query. Select name comma course ID from instructor comma teachers, where instructor ID is equals to teachers ID. Another example of using this where clause along with this Cartesian product is here. So, for example, we want to find the names of all instructors in the art department who have taught some course, and apart from that we also need the corresponding course ID. So, we are going to write select name comma course ID from instructor comma teachers. Now, with where we are going to specify two conditions. One is they belong to the teachers who are belonging to the art department, and they must have taught some course. For the teachers who have taught some course, we have the clause as instructor dot ID is equals to teachers dot ID. But apart from that, we also need instructor, we also need the department name is equals to art. So, we are going to write instructor dot department name is equals to art, and art, as it is a string, we need to enclose it in a single inverted comma. Now, here please be careful that the department name is being prefixed with the name of the table or name of the relation, which is instructor. So, the full query goes like this: select name comma course ID from instructor comma teachers, where instructor ID is equals to teachers ID and instructor dot department name is equals to art, and with our the table which we are referring to, this is going to generate the result of two columns. One is name and another one is course ID, which is shown on the screen, and here are the different course IDs which are taught by different we can say instructor here. So, here we have seen the Cartesian product, but Cartesian product along with the where clause, which corresponds to the selection of the select clause of the relational algebra. Now, please recall the example of that arithmetic operation in which we have seen salary divided by 12 and we have renamed that field. So, apart from renaming the field, the SQL allows renaming relations also using that as clause, as we have seen in the earlier example. So, for here let us say we need to find the names of all instructors who have a higher salary than some instructor in computer science. Now here what is happening, we need to kind of apply the join, or we can say apply the product of the instructor table onto itself. So one table we will be taking as T, renaming as T, and the next instance of the table of the same table will be renamed as S. So our query goes like this: select T dot name from instructor as T, comma instructor as S, where T dot salary greater than S dot salary. So that means it is, we are looking for the instructor who will have a higher salary than some instructor in computer science, and S dot department name is equals to computer science. So the relevant part here is we are going to rename the table instructor. We have taken we can say instructor multiple times. We can say we are going to take the instances of the instructor table. So one instructor table on which we are going to perform this query, which this is basically related to joins. So one on which we are going to perform is renamed as the table T, and another one is renamed as the table S. So we will say select distinct T dot name from instructor as T, comma instructor as S, where whatever conditions you want to write. Now please note the use of the clause distinct here. Distinct here is going to give me all those different names by allowing the removal of the duplicates. So here also in the rename operation, the keyword as is optional and may be omitted. So wherever we have written instructor as T or we have written instructor as S, we can simply write instructor T or we can simply write instructor S. So the keyword S is the use of keyword as is optional here, and if you want to omit, you can omit, just for the kind of we can say sake of simplicity. So this was actually the rename operation, and we have also seen the Cartesian product operation along with the where clause, which is specifying some of the criteria which tuples need to satisfy. Apart from that, we are going to also read about the string operations. So string, as you all understand, that it is basically a group of characters. So SQL includes a lot many string operators, string matching operators also, and string operations also, other string operations also. So presently we are going to focus on the string matching operator for comparison on character strings. So the operator, it is having two special characters to be used. The operator here is like, and this like, the operator like is going to use the patterns, and these patterns will be specified with the help of two special characters. One is the percentage sign and another one is the score. Underscore. The percentage sign matches with any substring. So percentage you can say is any, and the underscore here, the underscore character matches with any single character we can say, while the percentage sign is going to match with any of the substring, while the underscore stands for only one character. So for example, we want to find the names of all instructors whose names includes the substring DAR. So for example, we have a name, let's say Majumdar. So that is going to be kind of taken out. So we are going to write select name from instructor where name like within the percentage, within the single inverted commas, percentage DAR percentage. So what is happening, this percentage is going to look for any substring. So any substring before DAR, any substring before after DAR would do. So, this is going to look for all those names which are including the substring DAR anywhere in the name. Now, for example, here we have used the percentage as the matching character here. Now, what if we want to use that as the key value, as in we want to match the string, let us say 100%. So, we are looking for the term 100%. So, how are we going to write? So, for example, look for the percentage where look for the name, select name where percentage like 100%. So, for this we need to write, we need to use escape character, which is the backslash, and we need to use this backslash as the escape character just before the percentage within the 100%. So, we will be writing our query, and with the like clause we are going to pass 100, then an escape character, which is the backslash, and then we have this percentage sign. So, in this way this can be used along with the escape characters also. So, for example, if we want to write intro percentage. So, intro percentage matches any string beginning with intro. If we are going to kind of we write percentage intro percent, that means any intro placed anywhere inside the inside the string which we are looking for. For example, we need to write percentage comp, percentage matches any string containing comp as a substrings. But here one thing which we need to be very careful is these patterns are case sensitive. So, for example, we are going to write percentage comp in capital, or we are going to write percentage comp in small. That two are that two are different, these patterns, because these patterns are case sensitive. So, your percentage was there for kind of in order to match with the any of the substring. Now, if we want to look for the specific number of characters, then we need to use the underscore. So, for example, if we are going to write 3 underscores, then this will match with any string of exactly 3 characters, and if we want to if we are writing 3 underscore and then a percentage, this will matches any string of at least 3 characters. So, here is the difference between the two. The first one is going to be going to look for any string of exactly 3 characters, but the second example, which is containing 3 underscore characters and a percentage, will match any string of at least 3 characters, and after those 3 characters anything could be there. So, your percentage is for any substring, while your underscore is for one specific character. So, here we can say that in this lecture we have seen apart from recapping our the previous the where and the from clause, we have started with the Cartesian product, and apart from Cartesian product we have also seen the rename clause for fields as well as the rename clause for your relations, and we have also seen pattern matching in SQL. So, here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed it. I will see you in the next lecture. Till then, take care. Goodbye.